2.5 liters of air is at 20 degrees Celsius. What is the new volume if the temperature increased to 65? So we're looking for the new volume. So that means we're going to be looking for V2. So that's the volume after a change has occurred. So let's write out what we do have. So we have a 2.5 liters, that's a volume. Since we're looking for V2, that must be our starting volume. So our V1 is 2.5 liters, is at 20 degrees Celsius, so we have a temperature. Since it's within the same sentence as our starting volume, that must be our starting temperature. So our T1 is 20 degrees Celsius. I need to make sure I go ahead and convert that to Kelvin. We always have to convert to Kelvin. So in Kelvin, that would be to 93. And then we have also another temperature. So this is after the temperature has increased. So that means that's a T2. And that's 65 degrees Celsius. Again, go ahead and convert that to Kelvin. And finally, V2 is what we're solving for. So since we're dealing with temperature and volume, we need the formula that involves just temperature and volume. V1 over T1 equals V2 over T2. So I'll go ahead and plug in what I have. So my V1 is 2.5. My T1 is 293. My V2 is what I'm looking for, so that's going to be my X. And my T2 is 338. When I have two fractions like this, the best method is to cross multiply. The way we do that is we take whatever's on the top and we crisscross multiply by what's on the bottom. So we have 2.5 times 338, which gives us 845. And we're going to set that equal to multiplying the other two. So x times 293 gives us 293x. And if we want to get the x by itself, we need to divide both sides by 293. That will cancel out. So we have 845 divided by 293, which gives us 2.8, or 2.9, about 2.9 is our x. And since we're solving for a volume, that is going to be liters. So 2.9 liters would be our answer.